Hello guys, we want to enter part 2 of circular motion. This aspect we want to be looking at circular and vertical circle. We are going to be discussing a horizontal circle, and we are going to be looking at banking. Now, let's draw a diagram. This is a vertical circle. This is a vertical circle. This is example of a vertical circle. Now, let's have the center here. Let's have a bucket. Let's take this one. Let's say this is a tension in the string. There's a string attached to the bucket, acting what? Now, if the bucket has to pull out of this circle, it has to pull tangentially to the circle. It has to pull tangentially to the circle. So that means if the body that is moving in circular path has to pull out from the circle, it has to pull out tangent to the circle. That means if the tension is not enough, please take note of that. Another thing again you need to know is that what? The weight will be acting downward. The weight is mg. This is theta. This one will also be what? Theta. Now for the body to move in the circular path, there have to be what? This tension have to produce a force that is higher than what is the opposing force. What is the opposing force here? This is a vertical circle, don't forget. Vertical circle. So in that case, if you resolve this one now, resolve this, what do you call it? The mass to the direction of the string, we would have what? Mg cos theta. Because this one is also what? Cos theta. This is a bucket. This is a bucket. Now, in this case now, if this one is acting downward against the tension upward. Now, for this body to move around the circle, there must be the help of what? Centripetal acceleration. And centripetal acceleration, or what we call centripetal force, to move around the circle. What enables this body to move? As I explained before, I said it tends to act through the center and enable the body to move with an acceleration around. So that means that, and don't forget, for a body to move around the circle, now we said what? The speed must be what? Constant. This fits that what? Uniform what? Circular motion that helps the body to accelerate round the circle. So that means T minus what? Mg cos theta is equal to Ma. So that means the tension, provided what? The string does not cut, T is greater than what? Mg cos theta. Please take note of that. So now the net force is what? Upward minus downward. That is net force, which is equal to Ma. This is centripetal force. Now, centripetal acceleration, and everything there is centripetal force. This is tension. This is the resolved weight along the strings. Resolved weight along the strings. So what do we have now? I want to have what? T minus what? Mg what? Cos theta is equal to what? Mv square over R. Now, listen, this is the formula for what? For vertical tension. So this for vertical what? Tension. Now, but listen, there are conditions upon which what the formula will what can change. The first condition we want to look at for this formula for tension is what? Vertical tension. This is T, this is a vertical tension, this one. So if the bucket is at the top, that is to be at the top means to be here. If the bucket is here, now it produces what we call a minimum tension. If the bucket is here, how will the tension which is acting downward, they have less work to do. So in that case, because it's now moving in direction of there will be more effort, more force in this direction to assist the tension force. So in that case, it's not like here when it's against. Here it was just like this one is summation of forces. Now, what happens is that T minus, don't forget that at the top, theta is equal to what? 180. At the top, if the bucket is at the top, theta equals to 180. So T minus what? Cos mg cos 180 degree equal to what? Mv square over r. Now, having done that now, what we're going to do now is what? Is to make what? Tension is already different. We have T minus mg. This one now become what? Minus 1 equal to mv square over r. And that will give us what? T plus what? Mg minus and minus plus equal to mv square over r. So T equal to mv square over r minus mg. So this is the tension, the minimum tension. Then at the top, that the tension at the top. What about at the bottom? This is the bottom. When the bucket is here, when the bucket is at the bottom here, what happens? So if the bucket is 2, if the bucket is at what? At the bottom. Bottom means to be theta equal to what? 0 degree. What happened? We have T minus what? Mg what? Cos theta is equals to what? Mv square over r. So if you put what? Theta to be equal to what? 0. T minus mg cos 0. Cos 0 is 1 equal to mg square over r. Mg square over r. So we are going to have what? T minus mg equal to mv square over r. Finally, tension equal to what? Mg plus mv square, or mv square over r equal to what? Mg. So this one is tension. So that is to say that T equal to what? Mv square over r plus mg at the what? Bottom. At the bottom. So at the bottom, because this one will now come here to become plus. Don't forget. Let me write this one where? So now we have gotten our this maximum tension, T max, mv square over r plus what? And now, what if what? Theta, if theta is equal to 90 degree, that is to say when it's at the horizontal part, horizontal, when it's here. So it will now be equal to what? T will be equal to what? Mv square over r. So when at what angle will the tension in a vertical circle be equal to what? Mv square over r. When theta equals to what? Equal to 90 degree. Now let us what? See horizontal circle. So horizontal circle. And let us see horizontal circle. We'll talk about vertical circle. Now let's take the B part now, horizontal circle. Horizontal circle is something like this. this horizontal circle. Now, the tension is here. Let's say the body in focus is here. And rotate, this one is tied to the ceiling. Now, let's say the tension now. If you, this is the weight is going down, mg. The weight is going down, mg. This one will be acting towards the body like this. To be acting towards, like that means in that direction, rather. Now, so that can complement the tension there. Now, in this analysis now, the tension upward, this is theta. If you resolve this theta, this one is alternate angle to this. If you resolve the tension upward, we're going to have what? C cos theta. Then if you resolve it like this, you are going to have what? C what? Sin theta. Because this is what? And this is 90 degrees. Then there will be what? A centripetal force like this, in this case, the horizontal circle, which is equal to what? Mv squared over r. Now, let us consider the vertical aspect and the horizontal aspect. Now, you can believe you can actually what? Write this like this: T cos theta plus all square plus what? T sin theta all square is equal to, that means I want to form identity, take square of this one plus square of this one, which is now what? Mv square over r all square plus what? Plus ma plus mg all square. Now, having done that now, what we want to do now is what is common on both sides. What is common here? This one can be written as t square cos square theta plus t square sin square theta. If you open the bracket, it's equals to what? Mv square over r all square plus mg all square. That means I square this one plus this one. Rather, I also square this one plus this one. It's the same thing. So what do we have? T square is common. Cos square theta plus what? Sin square theta. What do we have there? I want to have it as what? Now, sin square theta plus cos square theta, or cos square theta plus sin square theta is equal to 1. So this one will give us ordinary t square equal to what? Mv square all over r all square plus mg all square. Now, what do we have? This one now becomes mv square over r all square plus mg all square. Class, what do we now have? Take square root of both sides. If you do that effectively, well, you're going to have it as what? T equal to square root of what? Mv square over r all square plus mg all square. This is formula for what? For vertical tension or horizontal tension. Now, I don't understand horizontal tension now. The next thing we should do now is we want to look at banking or analysis. Although in banking, we are going to look at it in the context of circular motion. And when we are looking at in the context of circular motion, we are going to look at this what? The design. That means we want to design in a way that what is centripetal force is used to navigate what? The motion of the body around a curve. We want to use centripetal force to navigate what? To navigate the, to help to navigate what? This one I can clean it. what? Want to what? So banking now, the last part is to what? To help the what? The use of what? Of centripetal force to navigate the body along a what? A curve. Or to navigate the curve, I put it, to navigate the curve without the help of what? Friction. Or without involving friction. Let me put that without involving, without the help, okay, let me put it that way, of friction. Smart guys. Now, now in the exam, if I say without friction, it might be too harsh. Because what about if we say without solely relying? You can say solely, without solely relying on friction. So banking is to help an object with the use of a centripetal force to navigate the curve without solely relying on friction. That is the best definition we can give this man here. So now, if we want to navigate the curve without solely relying on friction, let's take an example. Let's say this is a car, for instance. Now, there is a frictional force of a normal reaction here. Let's call it N. There is an angle at which it will what? To bank. Now, this is the weight of the car. Okay. Let's see. There's a what? Okay, let me say this angle. There's an angle here called theta. Now, for the car to be moving up, let's say there is a centripetal force that is balancing it there. Centripetal force. Now, if you resolve this now, resolve it. If you resolve it along the vertical, we are going to have it as what? At it, N cos theta. Don't forget that there is equal to theta and here is equal to theta. So here is equal to theta. Now, if you navigate that, we are going to have it as what? N cos theta is equal to what? Mg. Resolving it like this. Then also, if you resolve it like this, we would have N sine theta. And in that case, N sine theta now will be what? Will be balancing what we call the centripetal force there. The N sine theta will be balancing the centripetal force. Now, in this case now, we said what? N sine theta is equal to what? Centripetal, which is what we want? Mv square over r. Now, having gotten that, now, what we're going to do now, let's call this one equation 1, and let's call this one equation 2. So let us divide equation 2 divided by 1. I want to have N sine theta over what? n cos theta is equal to what? Mv square over r divided by what? Mg. Mv square over r divided by mg. So what do we have now? What do we have? We are going to have it as what? This one cancel this. So this one will be tan theta equal to what? M will cancel n, v square over r divided by g over 1. So what do we have now? Tan theta is equal to v square over rg. So don't forget that tan theta is equal to coefficient of friction. Therefore, the banking angle, the angle can also be equal to tan theta, which is tan theta equal to the coefficient of friction, which is equal to what? V square over rg. Now look at this condition in case they ask you in the exam. Now the conditions are to be stated like this. If tan theta, or if what is greater than v square over r, the body will what? Will slip or will skid. But if what? But if mu is equal to v square over rg, the body will not what? Or the car say will not what? Skid. So you now see where we are going now. So banking is to help an object with the use of centripetal force to navigate the curve without what? Solely relying on, like, we don't want to rely only on frictional force, but we want to bring in centripetal force in, so that they can be the help of what? Both centripetal force, that is what? Between the what? The tire and the what? Wheel, and the frictional force that enable the body to move what? From one point to another. That's the reason why we are using what? We are analyzing banking theory. So I believe that you understand it. But let's see, this one we have used tension. Let us finally use length. Let's use length to analyze it. Let's see how we can get something like this. Recall that if I say, look at this mg, I can say t cos theta equal to mg, then t, that means equal to this, equal to t sin theta equal to what? Mv square over r. Now if you use this formula, this one divided by this, you still get the same thing. But that's not where I'm going. Let me clean this now and use what? Let's call this one length L. Let's call this one radius R. Now we want to look at what? Relationship between what? Relationship between what? The length and radius V and G. We want to look at the relationship between what? Length, radius, V and what? And G. Now, if you want to look at that, from here to here is the radius R. Now, for me to calculate what? Here to this place, AB, I need to use Pythagoras. Don't forget, here is length from here to this place. So if I use my AB, which will give me us what? AB should be what? AB square equal to what? L square minus R square. Remember that here is hypotenuse. If you look at this, this is a right angle triangle. Here is adjacent. Here is hypotenuse. Here is opposite. So this is what I want to have. So AB becomes what? Square root of what? L square minus R square. Here is AB, adjacent side. This opposite facing the angle. This is the hypotenuse. AC is the hypotenuse there. So if you want to look at it thoroughly using Pythagoras theorem, it's simply telling us that AC, which is hypotenuse square, equal to what? Opposite square plus what? Opposite square is what? BC plus what? Adjacent square, AB. So if you look at it that way, that's what I'm going to have. Now, what? If you now make AB the solution of formula, you are going to have what? This one. So here is what? Square root of what? L square minus R square. Now, using Pythagoras theorem, here is what? Here is opposite, and here is what? Adjacent. Now, the opposite over adjacent equal to tan theta. So tan theta equal to what? R over square root of what? L square minus R square, which is equal to what? Tan theta is also what? V square over RG, which is what? If you cross multiply now, what do you have? GR square equal to what? V square square root of what? L square minus R square. So this is the relationship between what? The length, radius, velocity, and what? And gravity. In case you are asked to find the length and you are given radius, you can find it here. Don't forget G remains what? 9.8 meter per second square. So this formula can be used. We can also generalize. We can generalize by saying, finally, let me end it here. To end circular motion here, you can say tan theta is equal to V square over RG equal to what? N centimeter acceleration over what? G equals to what? We can say equal to what? Mu, and equal to what? R over square root of what? L square minus R square. So this formula for what? We can get our what? Theta through that. Recall that you can see solve for your theta as what? Tan inverse of what? V square over RG, which is what? The banking angle. This is the banking angle. We are talking about theta. This theta is what we call banking angle, which is the angle of inclination of the what? Of the object trying to move around a curve. Don't forget, banking is what? Is just what we want to use what? Centripetal force to what? Help to analyze what? A body around a curve without showing what? How a body can actually navigate their way around a curve without solely or more single-handedly depending on what? Friction only. Friction cannot do the work alone. We need centripetal force between the tire and the point of rolling of the object, and the what? We need friction between the ground and the object, which produce what? A normal reaction, which we use to analyze it. So please ensure you subscribe to my video. My name is Engineer Holiday, and I wish you success. Thank you.